Good day, everyone, to this Tech at Lunch session of February. Today we will talk about improved test quality for safety-critical Simulink models, which will be presented by Onur Kilinceker, I hope I pronounced it right, and Serge de Meijer. During this session, you can ask questions by chat or by raising your hand, which both will be addressed at the end of the session. So please don't hesitate to ask your questions. We will record this session and share it at a later moment. Thank you all for being here, and I would like to give the word to you, Serge.
Thank you, Miranda. Do you hear us? You do. So yeah, for people attending late, please open this QR code and go to Mentimeter so that we can see how many people are here and that we can also interact with you. So. There's a little thumbs up here, down. If you press it, we can see how many people are in the room. So that's good. So here's the QR code again. Right, and so this is time to start. I'm Serge de Meijer. I'm a professor in the University of Antwerp, and I will give this presentation together with Onur Kilinceker. He is one of my postdocs. Hi, Onur. Yeah. And so this is going to be about quality, software quality, and more specifically about how you can measure and improve the quality of tests for Simulink and Stateflow models. This is joint work we did with Duco, where we actually did a case study with this tool, and we're actually going to report about what we did during this case study. First, a little bit of context. Oops. The V model. Typically, if you talk about software development, people use the V model, and which means that we test first the user requirements, and we do acceptance testing against the user requirements. We have the system design, we have testing against the system design, and like that we descend in the V model all the way to the detailed design, where we perform unit testing. Many companies nowadays use in this detailed design MATLAB Simulink, which is a modeling and simulation tool, and from that they generate the code. And if they generate the code, then they can apply unit testing. And with unit testing, there comes coverage. And if this coverage, they can measure how strong the test suite is. So you can have tests here which are 100%, very strong, 88%, which is good. 50%, this is likely a place where you need improvement. And so what we did is we created a tool which measures coverage of MATLAB Simulink unit tests. This is important because we know from experience that the cost of fixing issues and the time for fixing issues increases exponentially the later you go in the development cycle or the higher you go in the V model. And so in that sense, you want to avoid that bugs, defects appear in production, because that's the worst that can happen. And there's a famous example of a Volvo car where there is a sensor, a camera, who was supposed to detect a pedestrian in front of the car. And when the camera detects the car should brake. However, there were rare circumstances where this communication between the camera and the braking system was not working as expected, and there was actually a risk that some pedestrian would have run over. Because of that, Volvo had to recall more than 120,000 vehicles to install an updated version of the software, and they also had to pay a big fine for that. So that's what people generally want to avoid, and to do that you need strong tests. Typically these tests are done late in the life cycle, and so they know then that the cost of fixing mistakes is a factor of 30. What we want to do is called shift left testing. So you want to test earlier in the life cycle. So if you detect defects there, it's cheaper to fix, and you avoid that they actually run into production. So that's what we did. We created MUT4SLX, which is a mutation testing tool for MATLAB Simulink models. Mutation testing is something special. This is one of the recommended practices in standards like ISO and ISC. and we're gonna, in a minute, explain a little bit what that is. But first, we want to go to this Mentimeter thing and get a bit of feeling of the way you test your models. And so in that sense, can the people in the room tell us whether they adopt a V model, whether they measure the coverage, whether they use Simulink Stateflow, or whether they use other simulation tools? Two people using other simulation tools. Simulink is used, V model is used. No measuring of coverage, unfortunately. So those are the 4 people. Okay, and then the real question, but yeah, given that nobody measures coverage, would be how many unit test the models? So if you would say yes, no, sometimes, or not applicable. Sometimes. So that's the kind of things we would like to see. And even a yes, so that's even what we prefer to see. This mutation testing is a way to measure the strength of a test suite. And the way it works is we will use a metaphor of an airline quality control system. I guess most of you already been to an airline, and then you have to pass your baggage into this machine with an X-ray where they try to detect whether there's dangerous items inside the bag. Dangerous items, guns, knives, certain liquids. However, what you also need to do is you need to test the quality assurance system itself, and so the person looking at these X-ray images, whether he's still awake. And the way they do that is they artificially inject faults into these models. So you see here, oops, my mouse is gone, knives or guns, which are artificially imposed on the image. If the person behind the X-ray machines sees the items and flags them, then it's okay. Yeah? But if he doesn't detect them, you know that he's falling asleep, and then you probably should replace him because he's not strong enough. And so this is a similar metaphor we use for mutation testing. And now I will hand over to Onur, who will explain the details on how we do that for MATLAB Simulink.
Thank you so much, Serge. Hello, everyone. Mutation testing is a fault-based software testing method. So instead of injecting guns and knives into our models, we use mutation operators. And these mutation operators are used to manipulate our system and our model to create faulty models and faulty systems. And then after automatically generating these faulty models and faulty systems, we call it mutations, we automatically execute our test cases on these mutants and faults. And then we measure whether our test cases are capable of detecting these faulty behavior in our system. If our test case capable of detecting this fault, the mutation become killed. Otherwise, it will stay alive. If it is killed, which is a good sign for our test case, and which is represented as a green area in our test report we generate at the end of this procedure. And then in the report, we also contain mutation score, which is a powerful coverage metric for measuring quality of our test cases. And within collaboration with Duco, we already developed 15 mutation operators in here for Simulink and 9 mutation operators for Stateflow. And again, these mutation operators are mined from their bug database to generate faulty behavior of the system. This is a very important point. And you can see an example over here. For example, ROR, operator replacement for Simulink. In Simulink component, as you may see over here, which is this component represents less than equal operation. And we manipulate this operator with other possible options like equal or not equal or less than or others. And then we change the behavior of the system by manipulating this component in Simulink or Stateflow. And we already evaluated our solution, MUT4SLX, on open source, but still realistic examples, like for helicopter and aircraft elevator or auto transmission for Simulink, and for Stateflow cruise control, microwave aircraft, or automatic transmission. And then you may see in the slide that for Simulink, we successfully calculate the mutation coverage for existing test cases for helicopter system. The mutation score is 40%, which is a sign that there are lots of room to improve their test cases. And then first step is to generate mutants. And you see the time over here. Our tool is very fast for mutant generation. So in seconds, it generates hundreds or thousands of mutants. When it comes to mutant execution time, this time is calculated based on overall simulation time. So it is based on the number of test cases we have and the test execution time of our system. So, for example, for helicopter system, it took almost 8 hours to finish entire mutation testing approach. And Duco, we mentioned about Duco. Duco is a leading European producer of ventilation and solar shading systems, and their mission is to create healthy, comfortable, and energy-efficient indoor climate. And since 2021, we have been actively collaborating with Duco to develop our solution, MUT4SLX. And in this slide, you see a sample report which shows how the mutation score is represented with other complementary details. And here is the new thing, the Duco added their software development lifecycle. And they wanted to strengthen their test cases, therefore also calculate mutation coverage. And MUT4SLX was the confidence builder for their test cases and systems. And this sample report tells which parts of the model are well tested. For example, green area shows which area of the system is well tested, and on the other hand, which ones are under tested, which is represented by red. And this is one way how they implement shift left testing. They wanted to be sure that their unit tests cover more tests before they proceed to higher level of abstraction. And in the report, you can also see which component in the system is not tested very well. Within the below over here, you see which block is not tested very well, and you see which block is tested very well. And what is the impact as a result? What is the impact of MUT4SLX for Duco? The impact was the building the confidence for their test and for their system, and improving their test effectiveness by 7.5% in just 3 consecutive tool trials, our MUT4SLX tool trials. Again, I will give floor to Serge.
Yeah, thanks, Onur. Since the pilot's case with Duco, we also reached out to other companies doing a safety critical station. And in particular, we had a European project together with Alstom in Sweden, and this is doing rail. And so there as well is safety critical, so yeah, mistakes are not tolerated. And they also use heavily Simulink and Simulink tests. They didn't have any Simulink Stateflow test. And so we actually applied MUT4SLX in their context. We also mined their bug database to see whether we could add additional mutation operators, and based on that, we actually improved the MUT4SLX tool. And what we're currently are looking for, and that's why we do this Tech at Lunch, is that we would like to do 2 more pilot projects so that we could further improve our tool. And so in that sense, this is the final slide. If you're a company who has Simulink or Stateflow models, if you have associated unit tests, and if you have a bug tracking system, please call us, because we would like to set up a pilot study with you so that you can actually gain confidence, just like Duco and so just like Alstom did in their test suite. Thanks a lot. Any questions?
Yes. I don't see any questions yet. Anyone a question for Honor or Serge? No, I don't think so. Well then, Honor and Serge, thank you for this inspirational session. And thank you everyone for joining us here. And I wish you a very good afternoon.